Thanks, John. I hope I can live up to that big intro. Can everybody hear me from the back? So I don't need to use a microphone? Perfect. Well, appreciate the opportunity to talk with people today. I've had a great day so far talking to a lot of people. I was envisioning Wayne State to be some little college of about 10,000 people, and it's like, oh my crap, you got a lot of students here. So this is fantastic. Got big campus, lots of stuff going on, so it's exciting. So as Sean alluded to, I'm going to talk about contaminants, emerging concern, or emerging contaminants. We've kind of switched to the CECs as our new acronym as people thought, well, how long can emerging contaminants continue to be emerging? So we've shifted things a bit. But I want to talk about, first, to just make sure we're all on the same page in terms of what really is a contaminants, emerging concern. I'll do a little bit of background in terms of what they are so we know what they are, a little bit of organizational structure, how our project works and what we're after. And then I'll spend the rest of the talk on really highlighting our USGS research. I mean, it's just going to touch on certain aspects. We've got 15 years of research, so I can't talk about everything, but I want to give you a sense of the breadth of things we're doing, so I'll kind of touch base on a lot of different stuff. And I'll throw in a few highlights from other external research as well, just to show what kind of stuff is really going on this exciting topic. So what are CECs? This is, I consider this a big umbrella term. This really covers everything that's either not currently regulated or there's incomplete knowledge on fate and effects. So it covers a whole range of things like pharmaceuticals and hormones, which most people probably consider with emerging contaminants, but it's disinfection byproducts, mycotoxins and phytoestrogens, kind of natural occurring compounds, detergent, fragrances, illicit drugs, which we haven't really got it into yet, but we see that others are seeing these compounds out there quite a bit, and obviously that's part of the chemical mixture signature. So we're going to get into illicit drugs hopefully at some time in the future. Algal toxins, microplastics, and even microbial aspects like pathogens and nanomaterials. So it's a whole range of things. And just I kind of like, if you haven't seen my talk before, what I like to do is pick one compound to kind of, so people can kind of get a frame of reference and can kind of picture what I'm really talking about is caffeine. We all have a personal experience with caffeine. So I kind of go through and see, well, what kind of products are caffeine used in now, and I was really surprised. Obviously people think about the sodas and the coffee and tea, but really it's not your father's caffeine. And I've been around a long time, so maybe it's I'm a lot older than most of you here. But you can see the kind of things you can use now that have caffeine. And certainly there's still caffeinated drinks, but now you can get caffeinated water, caffeinated beer. If you want, you can have your caffeinated waffle in the morning and pour caffeinated syrup on top of it. If you can consume it, you can make it caffeinated. It's just amazing why we would want caffeinated marshmallows, but there's obviously a market for it. But it's not just things that we use and consume internally for food. It's even things we use for our daily lives. There's caffeinated lip balm, caffeinated showers. So if you can't wait for your cup of coffee or now your caffeinated waffles, you can hop in the shower, it lather up with this soap, and really start absorbing your caffeine right out of the blocks in the morning. Or you have caffeinated aftershave or caffeinated shaving cream. I mean, this obviously stuff works. Look how bright-eyed this guy is. So this is obviously a very good product. So there's all these range of things you can use and caffeinated creams. But the one thing I thought was the most bizarre caffeinated product I've seen out there is you can have caffeinated pantyhose. So it's these slimming tight. So you have this impregnated pantyhose with these caffeinated capsules that you absorb into your skin to tighten your skin and having a thinning basically weight loss. So as a scientist, I'd really like to see the before and after picture, because this after picture looks pretty good to me, but I digress. So again, that just kind of shows how chemical a society we've become. Anything that we use, and that's one of the take-home messages for me is I didn't really appreciate when I first started. Everything we use in today's society, as simple as drinking a cup of coffee, has the potential to become an environmental contaminant. I'd really think, hopefully, that people realize that, because when you start buying products, do you need all these products? Do you need antibacterial soaps or not? Because ultimately that can get in the environment and that can lead to a lot of issues. So one of the things that, this is the water cycle with the quotes, but I think this is this cycle, I think, is what's kind of captured the public's attention the most. So again, it's these things the products we consume, whether it's coffee or drinks or whatever, the products we use, whether it's toiletries and shampoos and so forth, ultimately ends up going down the drain, whether it's flushed down the toilet, washed down the drain, goes into the wastewater treatment plant. And when these plants were installed, these contaminants were never part of the equation. So and they're not currently regulated. So these plants are not out of compliance, but they're blasting through the plants, either partially removed or unremoved, and getting into our water resources. And everybody lives downstream of somebody else. And so ultimately, there's this recycling of what we dispose of. So, what you went through your toilet can go back into somebody else's drinking water. And I think that's really what's kind of captured the public's concern and attention. And the AP put out a series of stories in 2008 on pharmaceuticals and water, and these are the cartoons that came out, and certainly they're humorous, but there's a serious side behind that. There is pharmaceuticals in our drinking water. Is that something, do we need to be concerned about? I don't know. I think there's certainly two camps, and I'll get into that a little bit later, but that's certainly no question. When you have pharmaceuticals in your source water, these plants were not designed to take them out, so it's no surprise that things that are in your source water are going to end up in your finished drinking water. And this just kind of shows the increase in attention and mental focus on emerging contaminants that has taken place. When we first started getting into this, and this was way back in 1998, we were seeing papers coming out of Europe, and that's kind of how our light bulb came on, and we started looking at these compounds. Early on, again, this is just 6 target journals. There was just a handful of papers a year. It's very easy to keep up on the literature. 2002, as our paper came out, not that this was the cause of the uptick in the publications, but now just with these 6 journals alone, we're now approaching 500 papers a year. So that's good news. There's lots of papers, lots of effort, lots of knowledge being gained over the past several years, but it's almost impossible to keep on the literature like we used to. This slide's from Susan Glassmeyer, a colleague of mine from the EPA, and it just kind of shows the explosion. And right now that the exponential increase hasn't slowed down yet in terms of the volume of work that's now being put towards contaminants of emerging concern. Just kind of quickly how we got into the game. Back in 1998 September, there was a toxics meeting. There's a number of project chiefs are within the toxics program, and really we're talking about what kind of research is going to take us into the next century. And I was, as I mentioned previously, I was seeing papers come out of Europe. My colleagues were seeing these papers from our German and Danish colleagues about a small set of pharmaceuticals turning up in European water resources, and that kind of clicked the light bulb on for us to see, really are CECs entering our environment here in the States. And so we were fortunate enough to have a little bit of seed money where we had some chemists with methods development. So we came up with, I think there's 4 or 5 methods, trying to remember exactly now, looking at 95 contaminants of emerging concern. We tapped into our national presence. That's one thing with the USGS. We have a national presence. People are already collecting samples for whether it's pesticides or bacteria or whatever. We found the right sites that kind of fit what we were looking for in terms of potential sites. We intentionally biased our sites to where we thought we'd most likely find these compounds. We weren't going to find them here. It wasn't going to be an issue. And so obviously it was an emphatic yes, these compounds are in our water resources. This is from Scopus, so it's maybe slightly different what Sean showed, but basically this is our big paper. So really we quickly showed that yes, these compounds are out there. So we quickly evolved from this simple question of some methods development and this occurrence type question to now looking at more of this broader fundamental research questions where we noticed before is are they entering, and now it's not are they, but which ones are entering our environment? What are the sources? Is it landfills, wastewater treatment plants, livestock aspects? What happens to them once they get in the environment? What's the fate and transport? Do they absorb to sediment? Do they photodegrade? What kind of natural processes maybe having some attenuation? And because now my project in the toxics program is under what we call the environmental health mission area, these 2 bullets are one now we touched on before, but now this is our real end goal, is determining is there adverse ecological health effects, and also is there effects to human health as well. So those are really the fundamentals of questions we're targeting. And so now this is our organizational structure for the team, which is multidisciplinary, spread all across the country, looking at source to receptors. See, it's much more complicated. We certainly have our new methods and now also new approaches, and we have these mobile exposure labs, which I'll talk about later, which really drives this sources, fate, effects, and ultimately human exposures. And all these have double-headed arrows. So the kind of research we're doing in terms of finding things in the environment will drive us to develop new methods and new approaches, and new methods and new approaches will drive us to do more environmental and effects research. So that kind of shows just kind of organizational structure, how we rapidly evolved from kind of more of a simplistic design to this more holistic concept. So this talk about, obviously there's a whole range of sources from landfills and wastewater treatment plants and so forth. This doesn't show all of them. I'm kind of, for today, because there's not a lot of time, I'm only going to focus on those that are kind of more urban related, whether it's wastewater treatment plants, landfills and so forth. But there's a whole agricultural component that we're capturing as well. We're just not touching base with it now. But this does show that I won't get it much today, that these compounds are mobile and persistent enough that it's not just a surface water issue. They can get into the groundwater as well. So that this is a very, very important and global issue that needs to be tackled. Just talk about landfill leachate first. There's not been a lot of work done on landfills on emerging contaminants. So we wanted to look. The initial driver for looking at landfills is the recommendations for disposal of unused medications was not to dispose it in the toilet. We realized that that's a bad thing to do, but it was suggested just grind it up and mix your unused pharmaceuticals with some sort of undesirables, whether it's coffee grounds or kitty litter, and then throw it in the garbage. So basically, that was to prevent secondary use, so prevent kids from sifting through the garbage, seeing a pretty pill, and think it's candy. So it really had nothing really to do with preventing environmental contamination, but just a safety factor in preventing misuse of pharmaceuticals. But realizing that a lot of the modern landfills collect the leachate and bring it back to the wastewater treatment plant, we thought, okay, is that really solving anything in terms of preventing environmental contamination? So we want to get a sense of what is present in leachate. In our phase 1 sampling, looked at fresh leachate. So we're in a lot of modern landfills where there's leachate collection systems, so we can collect the leachate that's generated. And this is fresh leachate. So this is not leachate that's after it's had handling or treatment and disposal. This is just fresh leachate that's being generated within these landfill cells. I don't know if you can see it real well, but those pictures on the left there, you can see that landfill leachate really looks like tea. So it is very chock full of stuff. It takes some specialized analytical tools to look for things, a lot of interferences, and actually, it turns out we had to do a lot of dilution of these things because there's a lot of compounds at very high concentration. So I just kind of stole my thunder a bit, but that's basically what we found. So of the 202 contaminants we looked at, we found 129 of them. These are the top 4. This is bisphenol A, cotinine, which is a nicotine degradant. DEET, you're all familiar with the mosquito repellents, the insect repellents, and lidocaine. So these are found in just about every landfill we looked at. Every landfill had between 6 and 82 compounds present. So again, there's that mixture level where the median number of CECs we found in a landfill leachate was 31. And the bigger surprise for me is I wasn't surprised when we found things. I mean, landfills, we are what we dispose of. So we dispose of lots of things, so it's not surprising we find a whole range of stuff in our landfills. But I wasn't expecting to see basically milligram per liter level. So all these measurements here are in nanograms per liter. So I don't know if you're familiar with pharmaceuticals in general, we see maybe hundreds or several hundreds of nanograms per liter in an effluent. Now we're seeing millions of nanograms per liter of bisphenol A, for example. So we're in basically nutrient level concentrations of these compounds. So that's astronomically high in my mind. This paper was published just last summer. So these are the compounds that were found in at least half of the landfills we looked at. There was, I believe, about 19 landfills, if I remember right. Frequency detection across the top. Box plots, if you're familiar with box plots, this interquartile range is 25th percentile, 50th percentile, 75th percentile. You can see a whole range of stuff. Again, you can see your bisphenol A, which is in just about every landfill, and concentrations at huge concentrations. Even pharmaceuticals, very frequently detected, not as high. We're in the hundreds of thousands of nanograms per liter. And even estrone, again, we found more hormones than just estrone, but this is the only one that was in more than half of the leachates. So estrone is a natural hormone. It's very potent, and it's potent even to down to a single nanogram per liter. Bisphenol A, on the other end of the spectrum, is weakly estrogenic, but now we're talking about 5 orders of magnitude difference in concentration. So, is the estrogenicity when you're in millions of nanograms per liter, is that similar estrogenicity as to a natural estrone? But again, this is final leachate, so this is not what's being released into the environment. This is kind of a first stage. So we did a follow-up study in 2012, a phase 2. A lot of these were the same landfills. Some of them we looked at different landfills. In this case, we did final leachate. So this is after the holding and any sort of treatment of those leachates So it's basically what's going into the environment. It's not necessarily what efforts mix with the environment and maybe some dilution, but this is what's basically ultimately leaving the landfills and getting into the environment. And again, shows it's not perfect, but it's scattered across the country, best we can do with our limited budget. So again, we had about 22 landfills this time around. So real quick comparison of the fresh and final leachate. Some similarities, certainly see lots of stuff. We see actually of the top 4 almost identical, maybe slight reordering, but 3 of the 4 are the same in both fresh and final leachate. Again, there's this mixture issue, but you can see that it is somewhat decreased. So that handling, whether it's just sitting in holding ponds or actually some more active treatment, does cause some decreases. Still see that range, that large range from nanogram to milligram per liter. Again, we found a number that were in the milligram per liter, but bisphenol A actually, now we have a new record. We had 17 million 17 million nanograms per liter of bisphenol A. Again, just astronomically high. This is currently in journal review, so I'm hoping the next, actually any day now, I'm hoping to have good news on this paper. And so, in general, again, we have fresh leachate, and this is total CEC concentration. That's basically adding up all your detections. You see this is the median total CEC concentrations and how many exceeded 1 million nanograms per liter. Final, much lower. So you can see this is statistically different of these 10 landfills that were sampled in both the fresh and the final. So there is some decrease, but I still say there's a mixture issue, and we still see, I see pretty hot concentrations, even though not as hot as say the fresh. It's still much higher than we'd ever see or typically see in, say, a wastewater treatment plant leachate, or effluent, excuse me. Okay, so now let's move on to wastewater treatment plants. This is a source that everybody looks at worldwide. This is probably where most of our work has been done as well. And just want to show things that can affect what's coming out of a wastewater treatment plant. So it's certainly the type of waste you receive. Is there hospitals in the sewer shed? Is there colleges actually? Those kind of things. What's the technology of the plant? Is it a trickling filter plant? Is it an activated sludge? That'll have an impact. There's certainly temporal variability. What you do on the weekend, you wash more clothes, you have morning and night, weekend, weekday variability. You got hydrologic variability, whether you got storm events, if you have a combined sewer overflow, so that will affect what's released from the plant. And even changes in your population, whether that's seasonal tourism, college, and I'll show talk here or slide here in a little bit of events. Do you have sporting events, concerts, all those kind of things where massive amount of people come in and leave, and they can have impacts on what's being released through a wastewater treatment plant. So I want to just show a couple examples. This is a pharmaceutical manufacturing facility. So when there's a pharmaceutical manufacturing, this isn't the waste just from that. Basically, for the ones we looked at, they are discharging to a wastewater treatment plant. So they are basically a source to what's coming out of a wastewater treatment plant. When we first started looking at pharmaceutical manufacturing, we saw a paper from India. We're showing they were having, I'm trying to remember the numbers, but it certainly was tens of thousands of micrograms per liter, just huge concentrations. And we thought, well, that's interesting. What does happen in the U.S.? And some of our sister federal agencies, like, that's a third world country. There's no way that's going to happen in the U.S. Why would any industry have that much waste of things they're trying to produce for a profit? And we kind of like, okay, well, we've heard that before. So we wanted to look for these compounds. We had a few wastewater treatment plants where we're having some unknowns in our chromatographs, and they started looking at the libraries, and we're seeing that these look like they matched up. So we actually developed a method for these specific compounds, and then we did a study where we looked at a bunch of single samples from a bunch of wastewater treatment plants from across the country, and then we have 3 wastewater treatment plants. This NY1 is where there's no pharmaceutical manufacturing input, and these other 2 where there was. And this isn't a one-time snapshot. These are lots of samples over several years. So the general rule of thumb is for a pharmaceutical, for the most part, you shouldn't see a concentration, or you'll likely see a concentration of a microgram per liter or less. And this is actually a total of all these 7. So even for all these 7 total, for these snapshot of kind of more typical wastewater treatment plants, that rule of thumb fit perfectly. Basically, yep, we're kind of right at that line. Lots of detections, but most are pretty low. Same with this New York plant with no wastewater treatment or no PMF input. Basically, it's statistically no different than the national look, even when you got one site which measured multiple times. But these 2 plants are much different. We have 100-fold, 1,000-fold higher concentration. So you're looking at thousands of micrograms per liter. That's really heavy for a pharmaceutical. And so again, that was the first time that's been documented that pharmaceutical manufacturing in the U.S. Can contribute to pharmaceutical concentrations in the environment. And we're following up with this to see, do we happen to capture the upper end of the spectrum? We got a national study that we're in the process of writing a paper up to document that this is pretty on the high side, but you can get really high concentrations when you have certain types of industry in your sewer shed.